Okay, so we're continuing example 3. So this was our y of s that we obtained in the last video. So our goal is to find these coefficients, right? A, B, C, D, and E. And what you normally do, or what we have been doing, is we usually multiply, right, the LCD, which is this guy, to both sides of the equation. Excuse me. And then it works out nicely, right? We solve for, our A and B, or maybe A, B, and C. But here we have 5 coefficients that that we need to determine. So it actually it gets really ugly, and it's very hard to determine them. I mean, if you actually multiply this guy times this, it's very hard to find A, B, C, and D. So instead, we're going to use another strategy, which is to multiply both sides by, not by the LCD, but one of the factors. So I'm going to multiply both sides by s, let me get my pointer here, by s cubed. So let's see, maybe get some color here. So I'm going to multiply s cubed, right, times this, and then of course s cubed times that whole expression, right, which is really distributing s cubed. So what do we obtain? Okay, well, we get, this is nice, right, those are gone, so I get 2 over s plus 2 squared equals, and then again, multiplying that s cubed in, we're going to get a plus, and then bs, right, one s is going to be left over, plus cs squared. And then when you multiply this guy times this one and this one, right? We already did these guys. Nothing, simplifies, just because, again, there's no common factors. So let's go ahead and just write it in. So ds cubed over s plus 2 squared plus e, right, s plus 2, and that's a cubed. Okay, so we have this equation. Same equation again, just multiplied by s cubed. And we have terms, right, or factors of, right, so these are terms, but we have an s factor, and then we have an s plus 2 factor, right, our translation. And it's easy to work with one factor. So if they were all s's, then it would be fine. If they were all s plus 2's, they would be fine. But we have a combination. So I'm going to go ahead and rewrite this guy in terms of s to help simplify things. So this guy is the same, equals, okay, so that's a squared. I don't like how that looks. That's a squared. And we have, let's see, okay, so this is all the same, bs plus cs squared. And I can factor out, right, I'm going to factor out an s cubed, because I can, right? There's definitely an s cubed in there. So let's factor it out. So we have s cubed, and then what's left over, so we have the sky, that's not a d, that's a 2 there. So that's plus 2 squared plus e over s plus 2. Okay, so we've simplified things a bit, but we can, again, we want everything in terms of s, so I'm going to call this guy, right, this is a function of s, and notice I'm using capital F, I'm not using y of s, because that's we already know what y of s is, and I don't want to confuse it with f of s. And again, this should remind you of Laplace transforms. We're going to do that a little bit later. So again, that's what they have in the book if you're looking at the book. So let's again write this out. A plus bs plus cs squared plus, and let's just write s cubed f of s. Okay, so this is what we have. Okay, so here, again, this is nice. We only have A, B, C, right? We know there's a D and E in here, but let's just focus on the A, B, and C. So if I want to find A, for example, Well, we can definitely, I'm going to let s be 0, right? Because if s is 0, right, some terms cancel out. So if s is 0, so let's maybe write that out. If s is 0, then I get, well, on the left-hand side, right, that's just 2 over 2 squared, right, or 2 over 4, which is a half. And then if I input 0 in here, well, that's gone. This is gone, right? Anything with an s. So all of this is 0. So I'm left with a equals 1/2. Okay, let's go ahead and find b. And one of the strategies is we can definitely use differentiation to help us solve this problem. So I'm going to go ahead and I'm going to differentiate this guy right here. So I'm talking about, let's see, maybe, so I have this equation, right? I want to differentiate each side. So if I differentiate each side, I can, again, rewrite this and write this as s plus 2 to the negative 2, right? Use the power rule, bring down that negative 2, we get a negative 4. And if you work out the differentiation, we get negative 4 over s plus 2 cubed. So that's why they have that in the book. Again, if you're reading it. Okay, so let's differentiate the right-hand side. And if we differentiate, we obtain, let's see, we get b plus 2c. And then this guy, right, this is, I'm actually going to use a product rule. So if I use the product rule, I end up getting 3s squared, right, take the derivative of that guy, leave this guy alone, plus, right, leave s cubed alone, and then I'm going to differentiate my capital F of s. Okay, so let's go ahead and differentiate one more time. So if we, again, differentiate this guy, right, so that's really going to be the second derivative. Right, if we do the math, we're going to end up with 12 over s plus 2 squared. And then the right-hand side, right, just differentiating, we're going to get, let's see, what do we get? We get 2, and I actually forgot, there should be an s here. So then I get 2c plus 6, let's see, s times f of s, plus, again, using the product rule, 6s squared times the derivative of this guy, and move over here. And then I get plus s cubed, and then I'm taking the derivative of this guy again, so it's going to be double prime of s. Okay, so now let's go ahead and substitute let's substitute s equals 0 into both of these equations. So I'm going to call this equation 11 because that's how they refer to it in the book. So if s is equal to 0 in equation 11, okay, so let's substitute. So again, I'm looking at equation 11 right now. So I get negative 4 over, well, that's 0, so that's 8. So I get negative 1/2, right, or negative 4/8. And then I am substituting, so b plus, and then 2, well, all of these guys are gone, right? That's 0, 0, 0, 0. So we're basically done with this. This is nice. So b is equal to negative 1/2. And actually I just noticed an error here, so I want to change it before we get the wrong answer if I use this expression. So this guy, when we differentiate, right, that should be a 4. Okay, so now let's input 0 for s in equation 11. So if we go ahead and do that, we get, whoops, that's okay, so that's 12. So I get 12 over 2 to the 4th. So that's 12 over 16. So 12 over, right, 2 to the 4th, 16. And that's going to give me 2c, and then, right, all these guys have an s factor, so it's definitely going to be 0. And this is pretty easy. I mean, we can reduce this. Let's see, divide by 4. So we get 3/4 is 2c. So 2 times what number is 3/4? Okay, so then our c is 3/8. Okay, so I found, so far I have A, B, C. So now we need to determine E and F. And I'll go ahead and do it on the next video. So I'll do this in thirds, yeah, because it's a tedious problem, but a very important problem. Okay, so that's, again, the 2/3 of this problem.